Before we investigate the working principle of Bluetooth, we first have to take a look at the question: what is protocol? According to definition, a protocol is a convention or standard that control or enable the connection, communication, and data transfer between two computing endpoints. It can also be described as rules governing the syntax, semantics, and synchronization of communication. Protocols may be implemented by hardware, software, or a combination of the two. At the lowest level, a protocol defines the behavior of a hardware connection. For instance, Internet Protocol, IP, HTTP, stands for Hypertext Transfer Protocol used in web page design, and POP3 stands for POP Office Protocol 3 for email delivery of protocols that are commonly used today. So, generally speaking, Bluetooth is a layered protocol architecture that consists of 4 types of protocols, including core protocols, cable replacement protocols, telephony control protocols, and adapted protocols. First, we take a look on core protocols. Basically, it contains 6 components. First, for baseband, it controls the Bluetooth unit's synchronization and transmission frequency hopping sequence. Second, it manages 2 different link types, SCO and ACL, which transmit data and audio respectively. For the second protocol, Link Manager Protocol, LMP, is responsible for link setup between both Bluetooth units. It handles the control and negotiation of packet size used when transmitting data. It also handles management of power modes, power consumption, and states of Bluetooth units in the Piconet. It also handles generation, exchange, and control of links and encryption keys of authentication and encryption. The third protocol, Host Controller Interface, HCI, provide a uniform interface method for accessing the Bluetooth hardware capabilities. For audio channels, it manages audio transmission that can be performed between Bluetooth units using many different usage models. And for this transmission, it need not to go through L2CAP layer. And for L2CAP layers, its full name is Logical Link Control and Adaptation Protocol. It provides connection-oriented and connectionless data service to upper layers protocol. The following tasks of L2CAP including multiplexing, segmentation and assembly, quality of service, and group of abstraction. The last protocol of core protocols is Service Discovery Protocol, SDP. It defines how a protocol client's application shall act to discover Bluetooth server's service and their Bluetooth characteristics. It also provides means for the discovery of new services becoming available when the client enters an area where a Bluetooth server is operating. It also provides functionality for detecting when a service is no longer available. So now we talk about the second protocol, Cable Replacement Protocol. It is called RFCOMM Protocol. It aims at emulating serial ports, and it provides transport capabilities for upper-level service, such as OMAX. The third type of protocol is Telephony Control Protocol. It consists of mainly 2 types of protocols. First, Telephony Control Protocol Binary, called TCS Binary. It is a bit-oriented protocol that defines the signaling for establishment and release of calls between Bluetooth units. It also defines the signaling to ease the handling of groups of Bluetooth units. The second type of protocol is Telephony Control Protocols, AT commands. It is a number of AT commands that support for transmitting control signals for telephony control. It uses RFCOMM for transmission. And for adopted protocols, it contains mainly 4 components. First one is PPP, named the Point-to-Point Protocol. It is designed to run over RFCOMM to accomplish point-to-point connections. It is a packet-oriented protocol. The second one is TCP/IP, UDP or IP protocol. It allowing Bluetooth units to communicate over other devices connected to internet or other networks. Bluetooth, in this sense, acts as a bridge to the internet. The third one is OBEX protocol. It is an optional application layer protocol designed to enable units supporting infrared communication to exchange a wide variety of data and commands in a resource-sensitive standardization fashion. The last one is Wireless Application Protocol, WAP. It is a wireless protocol specification that works across a wide variety of wide area wireless network technologies, bringing the internet to mobile devices. Bluetooth as a web bearer can transport data between web client and its adjacent server. Bluetooth comparatively has a high mobility with other web bearers. So here we can see a Bluetooth protocol specs profile. We can observe that it is a layer structure of Bluetooth protocols. In general, core protocols are the base of the structure, while others at different depth positions. Some example of profile included headset profile for wireless headphone, then access profile for accessing the LAN through an access point. So, after go through the protocols of Bluetooth, let's see the network of Bluetooth. Bluetooth devices can establish physical links on basis of master and slaves. While one master device can control up to 7 active slaves in the valid range. This small ad hoc network with dynamic connection between nodes is called a piconet. Each device in the piconet has the ability to be either master or slave, or both at the same time. All transmission within the network have to go through master. Therefore, no direct transmission between slaves is established. Further, 255 devices can be copied to the piconet, which master can bring into active status at any time. Now, Bluetooth devices class 2 is commonly adopted along Bluetooth network, which provide valid range up to 10 meters and can be powered up to 100 meters using amplifiers. Transfer rates are commonly at 400 to 700 kilobits per second, while maximum rates can up to 721 kilobits per second. 2 or more piconets can form into a bigger network called scatternet, in which one node of either master or slave in a piconet acts as slave in another one. So here we can see a piconet or a scatternet diagram. Here, slave 4 in a diagram acts as both master and slave in 2 piconets respectively, joining up the 2 piconets. It can establish connection to standby devices, turning them into parking nodes. Active or parking nodes can switch roles at any time by each.